We're now going to learn about the first derivative test and walk through some examples. The first derivative test is used to find where a function has a local maximum or a local minimum. The first derivative test tells us that if f prime changes from positive to negative at a point C, you can see this down here in our graph. We have a point C, and our derivative is positive and then negative, which means that our graph is increasing and then decreasing, and that means that we're going to have a local max at x is equal to c. In a similar way, if f prime changes from negative to positive at a point C, here's C, and f prime is negative and then positive, so our function is decreasing and then increasing, and that means that we have a local min at x is equal to c. I always think that it helps to draw those lines because you can see easily that you have a max or a min. Let's now walk through some examples. We are going to use the first derivative test to find the local maximum and minimum values of f of x. Just to make things easier, I have written down some steps that we can follow. The first step is to find the critical numbers. The second step is to find the value of f prime to the left and right of each critical number. And then our third step is to just calculate the local maximum. That is going to be where f prime changes from positive to negative. And then find the local minimum, and that is where f prime changes from negative to positive. In our first example, we're given the function f of x is equal to x cubed minus 6x squared plus 5. For our first step, we are going to find the critical values, so we're going to start by taking the derivative. F prime at x is 3x squared minus 12x, and then we set that equal to 0. We can factor out a 3x, so we're left with x minus 4. And this gives us that x is equal to 0 and x is equal to 4. Those are our critical values. In our second step, we are going to take these critical values and we are going to put them on our number line. The nice thing is that spacing doesn't matter. So here's 0 and here is 4. And we are going to be looking at the value of f prime. Let me go ahead and highlight f prime so we can see what to look back at. Because f prime is a polynomial, when we look at the regions to the left and right of our critical numbers, we only have to look at our leading term, which is x squared. That term is positive, so we know that to the left and right, f prime is going to be positive, and then all we have to do is now just pick a point in the middle. I'm going to choose x is equal to 1, and we're going to have to see what f prime is. F prime at 1 is just going to be 3 minus 12, and that is negative. So we're going to put a negative here. And then let's go ahead and let's draw some lines. When f prime is positive, our function is increasing, then it's decreasing, and then it is increasing. Now let's look at our third step. We just have to find the value of the local maximum and local minimum. We are going to have a local maximum at 0. So let's calculate f at 0. Let me highlight this because this is what we're looking back up at to find f of 0. So f of 0 is just 5. Now let's calculate f at 4. That's where our local minimum is going to be. And this is 4 cubed minus 6 times 4 squared, which is 16, plus 5. And that is, let's see, 4 cubed is 64, minus 96 plus 5, and that adds up to be minus 27. So for our answer, we can say that 5 is our local max, and minus 27 is our local min. Before we go on to our next example, let's take a quick look at our graph. Our critical values are here and here. That's where our function changes from increasing to decreasing, as well as where our local max and mins are. And you can see that right here, at x is equal to 0, we have a local max. And when x is equal to 4, we have a local min. In our second example, we are given the function f of x is equal to x plus 2 sine x, and we're also given that x is in the interval from 0 to 2 pi. I always like to do a trigonometry example because I think students always find these challenging. Our first step is to go ahead and take the derivative. We have f prime of x is equal to 1 plus 2 cosine x, and now we're going to set that equal to 0. So we get cosine x is equal to minus 1/2. Cosine is negative in quadrants 2 and 3, so let's just say quadrant 2 and quadrant 3. And then let's think about the reference angle. Cosine is equal to 1/2 when x is pi over 3. So in quadrant 2, x is going to be pi minus pi over 3. I have a whole video on reference angles if you need to review that. And this gives us 2 pi over 3. And then in our third quadrant, x is going to be pi plus pi over 3. So this is 4 pi over 3. Let me go ahead and highlight these because those are our critical values. Our second step is to draw our number line, and we're going to place our critical values on the number line. We have 2 pi over 3, and then we have 4 pi over 3. And we are going to be looking at the value of f prime. So let's highlight this and highlight that. That's the f prime that we're going to be looking at. Let's also add to our number line that our interval is between 0 and 2 pi. What we have to do now is find a value for x in this interval, and this interval. For our leftmost interval, I am going to choose the easiest value I can think of, and that is x is equal to pi over 2. So f prime at pi over 2 is 1 plus 2 times cosine pi over 2. Cosine pi over 2 is 0, so we just get a value of 1. And that is greater than 0, so I'm going to come up here to our graph and put a plus. Now let's pick a point between 2 pi over 3 and 4 pi over 3. I think the easiest value is pi. Now we're going to compute f prime at pi. This is 1 plus 2 cosine of pi. Cosine of pi is negative 1, so this is 1 minus 2, which is minus 1. That is less than 0, so we'll put a negative in our middle region. Now let's pick a point in our rightmost region. Let's see, I think the best point to pick is going to be 3 pi over 2. So f prime at 3 pi over 2 is going to be 1 plus 2 times cosine 3 pi over 2. Cosine of 3 pi over 2 is 0, which is really nice. So this is 1, and it's greater than 0. So we're going to put a plus. Let's now draw some lines. Our function is increasing, decreasing, and increasing. So that is going to tell us that we are going to have a local max at x is 2 pi over 3. We need to find the value of the maximum, so we have to compute f at 2 pi over 3. Now we have to be really careful. We are now looking at our value of f of x. So let me go up here and highlight that in pink, because that's what we're going to be calculating. So we have 2 pi over 3 plus 2 times sine 2 pi over 3. This is 2 pi over 3 plus 2. Now we have to think. Sine of 2 pi over 3 is going to be positive because it's in the second quadrant. Sine of pi over 3 is root 3 over 2. So that means that's the same value for 2 pi over 3. So we're going to put down root 3 over 2. And this is then 2 pi over 3 plus root 3. And if we put that in our calculator, it is approximately 3.83. And we'll just label this as local max. Now let's find our local minimum value. That is going to be when x is 4 pi over 3. And this is going to be really similar to 2 pi over 3. We just have 4 pi over 3 plus 2 times sine 4 pi over 3. This is 4 pi over 3 plus 2. And now sine in the third quadrant is negative, so we're going to have a minus root 3 over 2. So f is equal to 4 pi over 3 minus root 3. You put this into your calculator, this is approximately 2.46. So we have a local min equal to approximately 2.46 at x is equal to 4 pi over 3. Let me go ahead and highlight local max and local min, and then let's go back up and let's look at our graph. Our critical points were 2 pi over 3 and 4 pi over 3. That is at this point and at this point. And we can see that we have a local max at 2 pi over 3 and a local min at 4 pi over 3. Let's now look at our third example. I wanted to do this problem because it has something in it that is not in the first two problems that we just looked at. We're going to start just like we did with our first two problems by taking the derivative. F prime of x is going to be 1/3 x to the minus 2/3 minus a minus 2/3 times x to the minus 2/3 minus 1. Let's now rewrite this so it's going to be a little bit easier to work with. Let's write the first term as 1 over 3x to the 2/3. And then our second term is a plus 2, all divided by 3x to the 5/3. Now let's go ahead and let's get a common denominator. That is going to be 3x to the 5/3. We need to multiply this term by x to make it x to the 5/3. So we have to multiply by an x up on top. So this is just x plus 2 in our numerator. Let's go ahead and highlight this because this is our derivative. To find the critical values, we are going to look at where the derivative is equal to 0 to start. So we're going to set x plus 2 is equal to 0. This gives us that x is equal to minus 2. I'm going to highlight that because that is a critical value. Now we are going to look to see where the denominator is equal to 0, because that can also be a critical value. So we're going to have 3x to the 5/3, set that equal to 0. So that gives us x is equal to 0. Now, we can't just assume that this is a critical value. We have to be really careful, and we have to go back up to our original function and see if it is defined at x is equal to 0. Because of the term x to the minus 2/3, our function is not defined at 0. So x is equal to 0 is not a critical value. It is always good, though, in our next step, step 2, to include this point on our number line because it can be a point where our function changes from increasing to decreasing or vice versa, although we know that we are not going to have a local max or min at that point. Let's go ahead and let's draw our number line. I'm going to put the point x is -2, and then I'm going to draw a dotted line at x is equal to 0, just to remind us that our function isn't defined at that point. Now what we have to do is pick a value in each of these 3 regions and see what f prime is equal to. I'm going to highlight f prime in yellow because we know then to go back up and look at the yellow function to find our value. There's a lot of points that we could pick for x is less than -2. I'm just going to pick x is equal to -3. So we're going to find f prime at -3. Looking back up to our formula in yellow, we have a -3 plus 2, all divided by 3 times -3 to the 5/3. Our numerator is negative, and then our denominator is negative. So this is going to be positive greater than 0. So let's put a plus up here in that region. Now let's pick a point between -2 and 0. Let's pick -1. So we have a -1 plus 2, all divided by 3 times -1 to the 5/3. The numerator is positive, and then the denominator is negative. So this is negative, less than 0. Put a negative there. And then we have to check one more point. Let's check over here on the right, f prime at 1. This is going to be a 1 plus 2, all divided by 3 times 1 to the 5/3. And we can see that that is all positive. So let's put a plus up here on our graph. Let's go ahead and now draw some lines, increasing, decreasing, increasing. So this means for step 3, we can see that we're going to have a local max at -2. So let's find our function at -2. Now we are going back to the pink highlighted function up above, and we're going to substitute in -2. This gives us -2 to the 1/3 minus a -2 to the -2/3. This is pretty involved. Hang with me. This is -2 to the 1/3 minus 1, all divided by -2 to the 2/3. Now we can get a common denominator of -2 to the 2/3. This gives us this term multiplied by -2 to the 2/3. So that's really nice. This just gives us a -2, and then we have a -1. So we have a -3, and then we can say -2 squared is 4. So we have a -3 over 4 to the 1/3. And if you put that in your calculator, it is approximately -1.89, and this is our local max. Before we end, let's go back up and look at our graph. I already put in that we have a critical point right here. That is at x is equal to -2, and we found that we have a local max there. You can also see from this graph that our function is undefined at x is equal to 0, just like we calculated.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.